This video will demonstrate how to set a weld mode and mode parameter recipe for the GSX using explicit Ethernet IP messaging. For this example, Rockwell Automation Studio 5000 Logix Designer is used, and the GSX EDS file has been installed. In the controller organizer tree, a subroutine for set weld recipe has been created. The GSX recipes can be remotely changed using explicit messaging. The process for changing and saving a recipe is multi-step. First, the token must be set to 1 to allow set messaging from the PLC to the GSX. Second, if the active weld mode is changed, the new weld mode value must be messaged. The weld mode is represented by a number. Third, the parameter value for the weld mode is messaged. Lastly, to complete the recipe setting, the recipe must be saved to the active recipe. In this example, a recipe to weld by energy is messaged from the PLC to the GSX. The weld mode number for weld by energy is 2, and the energy level is 50 joules. The weld mode and parameter attributes, object class, and data types are in the GSX Ethernet IP user guide. The object class and instance for changing the active weld recipe is 81 and 1. The attributes for weld mode and mode parameters are 4 and 5, respectively. The attribute, object class, and service code for saving a recipe is 1, 80, and 10. To start, in the Set Weld Recipe subroutine, create a rung and contact to initiate the set recipe messages. For the contact, create tag set recipe. Move instructions will be used to set the attributes for weld mode, mode parameter, and saving the recipe. Add 3 move instructions. For the first move instruction, set the source to 2. 2 equates to weld by energy mode. For the destination, create tag set mode request. The data type should be a double integer or 4 bytes. The second move instruction sets the mode parameter. Set the source to 50. 50 is the energy level in joules that will be used for weld by energy. Create tag set energy request. The data type should be real. The final move instruction is for saving the recipe. Set the source to 1 and create tag save request. The data type should be a short integer or 1 byte in length. Next, add message instructions. Create message tags. Set mode message. Set energy message. And set save message. In the set mode message configuration, set the service code to 10, the instance to 1, the class to 81, and the attribute to 4. Configure the source element to set mode request. Set the source length to 4 bytes. For the destination element, create tag set mode response. For communications, browse to the Ethernet location of the GSX. Select OK and close. In the Set Energy Message configuration, set the service code to 10, the instance to 1, the class to 81, and the attribute to 5. Set the source element to set energy request and a source length to 4 bytes. For the destination element, create tag set energy response. Set the data type to real. For communications, browse to the Ethernet location of the GSX. Select OK and close. In the Set Save Message configuration, set the service code to 10, the instance to 1, the class to 80, and the attribute to 1. Configure the source element to save request and set the source length to 1. For the destination element, create tag save response. Set the data type to short integer. For communications, browse to the Ethernet location of the GSX. Select OK and close. The GSX, after saving a recipe change, requires a short processing time before the recipe can be used. In this example, a 250 millisecond timer is added to set a recipe done bit. When the done bit goes true, this signals the recipe is saved and ready to use. To start, add 3 contacts for each set message's done bit. Next, add a timer with tag, message delay timer. Add the timer's done bit to the rung. Preset the timer for 250 milliseconds. After the timer, add and create bit coil, set recipe done. This completes the example tutorial for setting a weld recipe using Ethernet IP explicit messaging. This program, and other example programs, can be downloaded from the Branson GSX website